Okay, welcome to part one of the decimal series that I've made. We're going to look at decimal basics. So I'm going to click here. So the thing you need to know about decimal numbers, and it's important to think about decimal numbers this way, think about them as living in between whole numbers. For example, a number like 2.3 shows a value that is greater than 2, but less than 3. So imagine dividing the line between 2 and 3 into 10 even spaces. And that's where we get the word deci from, the idea of 10. So that would put 2.3 right here. So we can use orange relational rods to represent a whole, and then the other rods to show a decimal value. And this is very good for simple decimals. So here the orange rod represents the whole, and the blue is 0.9 or 9/10 of the whole. With this one, the green is the dark green rod as opposed to the light green rod over here, is 0.6 or 6/10 of the whole. So my question to you is, what would the purple be? I'll give you a hint. That's 0.1, that's 0.2, that's 0.3. The purple would be 0.4 or 4/10 of the whole. So that's the decimal basics and decimals at 10th, or what we sometimes say as to one decimal place. And on the next slide, we're going to start looking at the hundredths. So using money is probably the easiest way to see decimals to the hundredths in a concrete way. So we think about something like 1.85. We can think of the loonie as the one, the whole. And then the 3/4 and the dime create the 0.85. Or 3.33, we have our three wholes, and then 33. So money is definitely an easy way to think about it. Now, when working from tenths to hundreds to thousands, some students think a number is getting bigger. And what I need you to understand is that with a decimal, the number is just actually getting more precise. So let's say we have these three runners and they cross a finish line, and it takes both of them longer than 8 seconds, but less than 9 seconds. So who wins in this race? So if we look at their time to the tenths, we might find that all three of them crossed at 8.4 seconds. So that doesn't help. If we go to the hundredths, maybe we find out that they all crossed at 8.47 seconds. Maybe the only way to find out the answer is to go to the thousandths of a second to see if there's a difference. So let's zoom in on these runners and take a look. So this runner here crossed at 8.475. So 8 and 475 thousandths of a second. This runner here at 8.476. And this runner over here at 8.477. So here we find that this first runner has the fastest time, but really only by a difference of 1,000th of a second and 2,000th of a second there. Okay. So if we think about those runners' times, 8.475, 8.476, and 8.477, they're still numbers between 8 and 9. They are still numbers between 8.4 and 8.5, and they're actually numbers in between 8.47 and 8.48. So really, the number didn't get bigger, it got more precise. So we often think of infinity as a really large number, but there's also an infinity between two numbers. We can get infinitely smaller. And I think this little graphic really kind of shows it, because we can keep zooming in and getting infinitely smaller and smaller and smaller. So this is the activity. First, I've got a study jam link for you here. So if you go to that study jam, it'll reinforce some of the things we just talked about. And then I'm going to ask you to round the following decimals. So round each one of these decimals. Be careful what I'm asking you to round it to. I'm asking you to round to the 10th, to the 100th, to a whole number, okay, or to the 1,000th. And when you're done with that, you're done with decimal basics and you're ready to go on to addition of decimals. All right.